last section for chapter 12, polymers and plastics. So polymer means many mers, right? Polymer. Polymers are long chain-like molecules composed of repeating units. The repeating units are called monomers, so one mer. I'm not really sure what mer is off the top of my head. It just makes me think I should go look that up. But anyway, you get the idea. So natural polymers exist. Your body is full of them. Starches, proteins, DNA are all polymers. And then we also have synthetic polymers such as PVC, styrofoam, nylon, plexiglass, very useful types of substances. Most polymers are durable. They're long-lasting. They're not going to just like fall apart because we've got long molecules. The long molecules are going to have greater intermolecular forces. They're going to have higher melting and boiling points, and so they'll be less likely to degrade. If you want to break or tear a polymer, you either have to overcome the intermolecular forces holding the pieces together, or you have to break covalent bonds. The stronger the intermolecular forces are, the harder it is to break it apart. There's different kinds of polymers. Polyethylene is the simplest of the synthetic polymers. So this is the monomer for polyethylene. This is the ethylene molecule. Is also called ethene. So ethene is the name that we learned to call it because it's got two carbons, and two carbons is the prefix F, and then ene instead of ane means there's a double bond. So this is ethene, but it is also often called ethylene, and so that's why it's polyethylene. So these monomers, these ethene or ethylene molecules, can react together and form long chains. And the long chain is called polyethylene. And so here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it could be thousands of them. These are called addition polymers. The monomers combine to form the polymer without losing any atoms. Nothing gets kicked out. That's what an addition polymer is. When you make a polymer, you can't always exactly control how those monomer units combine with each other, but you can influence them. So a high-density polyethylene is going to have very little branching. They're going to be straight chains like this one. When you have lots of very straight chains, they can get very close together, and they can get, so the intermolecular forces are going to be stronger. You're going to have a higher density because there's less empty space in there. You'll get good strength and good heat resistance. Remember we talked about with nonpolar molecules that the shape had a big effect on the strength of the intermolecular forces. If it was more of a sphere, then two spheres touching each other can only have a small surface area where they overlap. But if you have two long pieces, then they can get a lot of interaction and they'll stick together. So that's what happens with high-density polyethylene. You have a lot of long strands that can nestle together very well. High-density polyethylene is used in milk jugs, among other things, because you don't want your milk jug falling apart and spilling the milk all over the place. A low-density polyethylene is going to have more branching. So it's going to have some branching in it, and then the pieces can't nestle together as much. So you're going to get a lower density. You're not going to have the intermolecular force strength, so the strength of the plastic is lower, and you're going to have less heat resistance. It'll melt more easily. And low-density polyethylenes are used in just common plastic bags. You get plastic bags made out of all sorts of different plastics, but you know, like your grocery bags and stuff are mostly low-density polyethylene. You can take the polyethylene and substitute some of the hydrogen atoms, and there's a whole class of substituted polyethylenes. Polyvinyl chlorine is one. It's abbreviated PVC, polyvinyl chloride. So you've got ethene monomers with a chlorine on them. So here we've taken the ethene, which was H2C, and we took one of the hydrogens off and put a chlorine in there. And then when you make a polymer of that, you get a chain that looks something like this. It's called polyvinyl chloride because another name for this is vinyl chloride. Don't ask me why, it's complicated. But PVC is used in different pipes and plumbing fixtures. And so if you put sprinklers in your backyard and you're putting those white pipes in, those are PVC pipes, polyvinyl chloride. Copolymers are going to have two different kinds of monomers. So far we've been looking at ones that there's just a single type of monomer and then they connect together. You can also have copolymers. Nylon is an example where you have two different monomers. And so these are the monomers, hexamethylene diamine and adipic acid. Those are the individual monomers. They will react via a condensation reaction and form this dimer. So monomer, one piece, dimer, now it's two pieces, and then you connect those dimers and you get a polymer. A condensation polymer is one like this, where when those monomers combine, an atom or a small group of atoms is removed from the structure. So there's addition polymers and condensation polymers. And then this is a table from your textbook showing some different examples. These are addition polymers, polyethylene, polypropylene. Here instead of ethylene, we've got propylene as the monomer, polystyrene, polyvinyl chloride. Different things that they're used for. Condensation polymers, polyurethane, polyethylene terephthalate, that's a form of polyester, and nylon. And so you've probably heard these different names, and so this is just a brief introduction to what those mean. Any questions?